Hi and welcome back to my shed. In this video I want to make a special mention to Tony Ray and family, to whom this video is dedicated. The subject of this video is about my Alba 1A shaper, if you haven't already guessed, and the work I've now done to fix some issues. In the past I have mentioned that some of the T-slots on my shaper had more than their fair share of damage, and that I'd have to repair them one way or another. A few weeks ago Tony contacted me with an offer of spare parts for my shaper. These parts were surplus to a complete renovation he has made to his Elliott 10M. Here are the three main parts laid out here. By the way, his refurbishment of his Elliott is top class, both in finish and adaptation, particularly with the drive system. Just over a week ago I went to see him, and as promised I took a tour of his workshop. Needless to say, I'm envious of his collection of fine machinery and equipment. I've put aside two other projects to produce this video, and while the hand crank here is in need of some modification, a new one really, it'll have to wait for now, and I'll continue to use this manky packing for now. While I'm at it, I'll look into removing the play out of this feed screw, and I'll also make a replacement feed gear and arm. My refurbishment, however, will not be a concourse strip and rebuild. It is basically a swap of well-worn parts for like new parts. I'll show you how I made a modification to the feed gear and ratchet lever later in the video, using spare material. The solution I'm using to clean all the parts is diesel oil. Why not? It's cheap, plentiful, and it works well. This retaining screw was stuck fast, so I ended up drilling it out. The ratchet lever or arm and rod are in good condition. It's the paintwork that's letting it down really. The main table came away quite easily. After removing the retaining nut and the hand wheel adapter bolt, the cross slide lead came out quite painlessly. The excess free play on the lead screw made journal at the ratchet end was because the casting on the main slide carriage had worn, and not the lead screw as I'd first thought. I had to slack off all the gib strips a little bit just to get the block support to slide off. The lead screw nut behind the cross slide had to be pushed out before the cross slide could be removed. Slacking off the vertical screw locking nut released the vertical jacking screw. I still had to work at it though to get it free. Six more bolts and two retaining plates had to be removed before the main slide would finally come free. The muck in this tray is used lubricating oil and old coolant. It don't half stink. After using the airline, my face was covered in millions of black freckles, except for of course where my goggles were. I looked like Sterling Moss after a 24-hour Le Mans race. This cross slide is the one that Tony gave me, and you can see that the slots are all in good condition. However, the T-slots on my old cross slide are badly damaged, and that's after a previous repair. My main table looks like Godzilla fancied a snack judging by the damage, but the new one's in fine shape. The two cross-slide assemblies are pretty much the same condition, except that the cross-slide screw bearing port on mine is badly worn. Before I reassemble the shaper, I need to clean the faces, and to do this I used a sharpening stone lubricated with diesel. Everything else got the diesel dunk and wire brush treatment. You can see that the casting on this cross slide has what I call blowholes in it. To be honest, almost all castings made during the late 30s and through the war are called war castings, and as long as they held up to the task they were good enough. Besides, resmelting during wartime was a costly business. There wasn't much crud in the thread of these studs, but they all look better, and that also includes the nuts. I suppose I was asking for it. The cross-slide nut is in fairly good condition considering the state it was in. Reassembling the cross-slide is a fairly straightforward affair, and because during the assembly there are plenty of spare setting screws and lock nuts, obviously I picked the best. After completely stripping both main slide assemblies, I selected the best of everything for the rebuild, as you would expect. For this part of the reassembly, the donor parts I used was the main slide body because my old cross slide screw fit perfectly and without any play. Everything else came from my machine. The donor gears were a bit worse for wear. The wear on the driven gear was plain to see. After reinstalling the vertical lead screw with a copious amount of grease, the gib strips were refitted. Refitting the main slide back onto the main body was a lot easier than I thought it might be. The vertical lead screw still needed a few whacks with a plastic hammer to get it to seat into place. And with the 6 bolts firmly supporting the 2 retaining plates, it was a simple matter of nipping up the gib strip bolts and locking them into place. Now that is a nice sight, to finally see the table going on and looking the part. With the cross-slide lead screw fitted, the locking nut and handwheel adapter can go back on. Up until now, the minimum feed rate on the cross-slide has been about 8 thou, that's 0.02 millimeters per stroke, which is fine for almost all jobs done on a shaper. But I want to make gears using the shaper, and when the shaper is at a critical part of the tooth making process, an 8 thou feed rate is quite a lot, especially when a large tooth is being cut along its flank. I need at least 4 thou, which is 0.01 millimeters or less. So I need to double the amount of teeth on the ratchet gear, and that means a bigger gear and a bigger ratchet arm. Now I didn't sit here and piecemeal a new ratchet arm to be a shiny and perfectly symmetrical component. There ain't enough time in the day for that, especially when the original part was only a hand-fettled casting. So as long as the bearing bore and the pawl are aligned correctly, the ratchet arm can be a reclaimed hockey stick for all I care. But I ain't got any hockey sticks, and I've only got a chunk of aluminium or aluminum, and all I'm going to do for now is gash everything out to a rough shape for later. This bit of round bar is the only bit of bar I've got that I would be able to extract a 50-tooth gear from. And yes, I said 50, and I know the original one was only 20 teeth. I think that'll make a difference. After centre drilling, I drilled through, then I finished the bore to 14.03mm, so as to securely fit it onto my shaper gear cutting attachment. When the other side was cleaned up and a spigot formed, it could be moved over to the shaper after it was deburred. Fortunately, I didn't need the cross slide action, which is a good job really. All the teeth for this ratchet were plunge cut. After the teeth were cut on the shaper, it was back over to the lathe to finish the bore out to 19.075mm, which is 3/4 of an inch plus a thou. Before going any further, I did a test fit. It couldn't go all the way on because some previous damage necessitated a brief visit with a file and some emery cloth, and then it fitted like a glove. All this marking out is just so that I can set the tapped hole as true as possible to the centre line of the drilled hole, the one I made in the lead screw, while removing the old seized grub screw. When I fit a modified grub screw into the new ratchet gear, the grub screw will act like a dowel key. This line will set it near enough against the set square in my drill vise. The tap I used to thread this to M6 was a starting tap, and it was a nice true fit. Now the process of extracting a ratchet arm from this previously roughed out form begins. These marks are for a rough guide only. And like I said earlier, only the pivot hole and the ratchet pole have to be in line with each other and to the right dimensions. So as far as looks go, forget it. I did most of the ratchet arm profiling on my rotary table and in the milling machine. To assist me with one part of that process, I used an old favourite. It's a modified Morse 2 tapered dead centre. The end piece is 14mm diameter and the tip is rounded off with a centre punch mark right in the very top centre. After rough drilling the pivot hole in the ratchet arm to 14mm, the dead centre would set everything fairly true, but most importantly rigid. Then with a few well placed clamps around the outside, the milling can commence. This bit of marking out is to give me something visually to work to. Now I must ask you to avert your eyes for the next minute and a half or so, especially if you're a machine shop purist, because this next bit isn't going to be pretty. I did say earlier that I'm not making any efforts to produce any concourse components. That's because I've got too much on at the moment and I'm holding off 2 large projects right now. The thing is, I'll need the shaper for both of them, and these donated parts came in just in time. You can start breathing again now. I'm just fettling off some sharp edges with a file. To rough out and finish the 22.25mm bore, that's 7/8 of an inch plus a thou, I mounted the ratchet arm in the 3-jaw chuck. A small boring bar and an inside mic assisted me with the rest of this part. I had to back bore here in order to remove the burr from the edge. I eyeballed the marking out for the oil hole here. Popping the oil hole in the side was a pretty painless affair. A 3mm centre drill provided the start and a very small funnel shaped entry hole before I drilled the remaining with a 3mm drill. This is the hole for the ratchet actuating rod connection. It is a 3/8 width thread. This is where the crosshairs, as I call them, are cut in. I used a hacksaw with two blades side by side to give me some width to the cut. It made it a bit easier to complete the filing as well. Mind you, the blade did skip out of the slot a couple of times and it's marked everything up, but I'll have to clean the skid marks up later. One of these slots has to be quite deep to allow the ratchet pull to fully engage into the ratchet gear. The other one, obviously at 90 degrees, has to hold the ratchet pull away from the gear. The ratchet pull and spring sits in a drilled and reamed bore. I did this little job while nobody was watching, not even the camera. That'll do. With the ratchet arm fully rebuilt, I popped it on before fitting the ratchet gear. The modified grub screw pulled everything together quite nicely. This is where I reconnected the actuating arm. The actuating arm timing wasn't set correctly, it was just assembled to get it working and to measure the new stroke distance combination. The shaper has got a nice calming rhythm about it, and I defy anyone who uses one that doesn't nod to the beat. According to my DTI, I've achieved approximately 0.087 millimeters per stroke. That's nearly 3.5 thou. That'll do. That's all for now. Thanks for watching. Bye.